of all the really cool things that we just brought out in version 1.195, and there are many things, probably one of the biggest was the routing curve. And what I'd like to do here is take you through a couple of really cool examples. I've got one here and I've got another one here, which has a pretty cool story attached to it. But I'll get back to this one in due time. I'm going to start with this one. And this is a manifold just off of a car which has got a big turbocharger on it, 6-cylinder. And the idea is to create these header tubes, runner tubes here. And in the routing curve is actually a really good way to do these things. So I'm going to step you through the process that I used. But before we do that, let's just take a little time to look at one of the other nice things from version 195, which is the cosmetic thread. Obviously there's some M10 threaded tapped holes here, and there's a thread on the stud here as well. And if I take a cross section through it, you'll see it behaves nicely with that as well. So shout out to that as a huge bonus thing for this already feature-packed release. Anyway, it's not going to be about that today. It's going to be about how to produce these runner tubes in between here. So the way I started this, and I'll show you the routing curve is obviously you're going to be at the heart of this, and we'll get to that in a second. But I start here in an assembly. You can see here I've got an assembly, and I've positioned, using mate connectors and using a couple of fastens, these off-the-shelf components, which are the merge collector here and the engine turbo, the exhaust flange, which is over here. These are bought components, so I'm not going to model them. I'm just going to buy them off the shelf, put them here, and then construct my things in between. And to do that, I'm actually going to create an in-context part studio. This is the context, and the part studio is going to be created, obviously in this context. So let's have a look over here, which is something I prepared earlier, and I'm going to roll it all the way back up to the beginning and take you through the process. So you can see here I've got the context from my assembly, and this is why it's in this ghosted out color. Now, of course, you can control the appearance of that just with this slider up the top. It's probably a good idea to leave you at this ghosted for the time being. But the first feature I did was a transform copy. If I look in there, I just chose the parts, and there's a lot of individual tubes here and the flange as well as this flange, and said copy in place. So that actually created a whole bunch of parts for me, which are copies of that original. Now, the reason I want this is that I'm going to actually construct a composite part of this plus the tubes, which is separate from these bought-in components. Because once it's all welded together, it's an inseparable part with its own part number, its own SKU for sale. So that's why I'm going to use this method. So referencing those things that came. Oh, by the way, these were referenced in from the outside from different documents, these two off-the-shelf components. Okay, and this is now going to lead us to the actual creation of the routing curve. So I'm going to show you first one here, already in place. And the routing curve is just going to create a curve, which takes me from one reference to another via some other things along the way. And once I've got that reference, I can sweep something along there. So I'm going to sweep the diameter of the tube and do whatever else. So let me show you what that kind of process looks like. I'm going to create a new routing curve just for fun. All right, so here's the menu, and it's waiting for points, and you're going to get points, vertices for this curve in from various means. One of them is to actually select from existing geometry. That's a good idea here because we've got some very good existing geometry. So I'm going to select a mate connector inferred at the center of this cylinder, like this. Now I've got my first vertex right there, and you can see here it's vertex reference is the part of that mate connector that we just created. Now, if we wanted, we could continue to add points and place them wherever we wanted to. But I'm going to do a sort of a shortcut here. I'm going to add point on axis drag. And what that lets me do is just drag, and it's going to add a new point there. And I'll drag down, it's going to add another new point there. And I'll drag maybe again this way. and keep going, right? And I can drag the path out. And now, if I want to change the position of that, I've got all of these different axes and planes that I can move it on. And you can see here the reference. Now, it's very, very important to understand what this is referencing. All of these subsequent points that we've created, this one, and now this one, are still referencing that original mate connector. They're just offset by a certain amount here. Now, we could key in a value if we wanted to. If we wanted that to be 150 instead, we can key it in. We can use the manipulator to do that as well. Very important thing is this checkbox here, which is show reference coordinate system. Now, that's this colored red, green, blue thing, and it's showing you what this is in reference to. Now, if you change this reference, which you can, that red, green, blue is going to go with you. So, and show you where the new reference is. It's really, really important to use this and keep it going so that you're not confused as to, is this point, it's 20 millimeters off what, right? Or it's 234 in the Y direction compared to what, right? So obviously we can see it here. It's minus 234 down from this. Right, so if we want to add another point, but not just drag it up, we're done with this sort of add point on axis drag. A really important tip, I think, for everyone at this point is that once you're done with that, remember to turn it off, because you'll confuse yourself later when you're trying to move things and it's adding more points. And you wonder, why is it adding more points? It's because you forget and then left that turned on. All right, so if we want to add a new point now, we could manually add the point like that. And now that point is on top of the old point, so we're going to have to move it. And you see how it is here. Now, instead of just moving it up in space, I'm going to put it in the middle of that. So I'm going to delete that reference and choose that new reference to be that mate connector. Now you can see it's 0, 0, 0 with reference to that one. So it's all, and you can see how that reference coordinate system, the red, green, blue triad here, is now moved over to here, seeing that it is now the reference. Now I'm actually going to bring that down in the Z direction by about 50. You can see that I want to type it in instead. That was me typing. And I'm going to add one more point. Now it's going to add it again at that point with respect to that mate connector, but I'm just going to type in 0 so that is all right bang, smack bang on that mate connector. So you can see my new point, my first point, second point, third point, fourth point, fifth point, sixth point. All right. So there we are with points. Now it's put in a nice interpolated spline, which is probably not, well, it's not what you want for this type of a tube fabrication. We'll get to that in a second. If you want to edit any of these points, you just click on them and you'll see the manipulator, which you can now move in all of the directions like that, or we can move that out like that. And you see how we can just keep manipulating this thing as we want. And it's a really good idea. You can have you can just switch between the top view. And now here's a really good tip for you. If you hit Shift and the arrow key, you can actually be shifting this in multiple units of 10, or in single units if you use just the arrow key on its own. Anyway, so that's the and you escape to get out of that, right? But the tip I actually wanted to show you was if you look at the top view and hit Shift arrow, we go in 90-degree moves now. So I can look at the right, I can look at the front, I can look at the top. And you get a good idea of the routing of a 3D curve like this if you go from these three kind of canonical directions. And that's why it's very convenient then to be able to move this in those planes. Just go like that, move it around here. Now we're moving it in the XZ plane, and we're going pretty well. Now, if we want to change this to a line of arcs and lines, or a polyline, we can do that up the top here. So we just choose polyline instead of interpolated spline. As you can see here now, we've got this polyline. So that's all good, but how's the gas going to go around that corner? It's not really until you put a bend radius in. So you can put a global bend radius for your routing curve of polyline type just by typing in a value up the top here. So let's go with 50. That's pretty good. And I think that's the same radius that I've used on some of the other parts of this. Now the good thing is that once we've got this global bend radius in and we continue to manipulate the curves, those radii will be updated. Well, they'll stay, and as we move the vertex as sort of the vertices there. Now, if you try and move something too far or too close to the previous segment, you'll see it goes into error, and it tells you that you can't do that. So the red bit is highlighted, the whole curve is highlighted in magenta. If we roll over, you'll see here it says cannot create bend at given point. It's always a good idea when there's a feature error to use this rollover in the tooltip, because we do our very, very best to show you exactly what the problem is at that given location. All right, so now that's not in error anymore, and we can successfully do that. You'll notice a couple other things. In the feature name, we actually have the length of the curve, so 537 millimeters. If you wanted to try and say get this to 600, because that's what the engine builder wants you to do, then you could experiment a little bit, just by moving these vertices around, and you can get it pretty close pretty quickly. Well, that's pretty close, and I had it closer before. And say, now you've got your 600 millimeter runner from here. Now, of course, it's going to be a little trickier when you have other ones to fit in. And so that's why it's a nice idea to be able to do these things sort of progressively, interactively. I'm trying to hit 600 millimeters as the target. I know the order from down the cylinders and where they are on this merge collector here, and I come up with some some schemes to try and get them all to be the right length with the right sort of bend radii, and within a reasonable packaging that we've got. So I did the same thing for those 6 routing curves, and I got it reasonably quickly. It didn't take very long at all, and I got them all within a few tenths of a millimeter of 600 millimeters total. So that's good. If I turn off those parts again, if I go back to here and take off the surfaces, you notice I can color these curves. So you just click on the curve, right click on it, and say edit appearance, and you can set your own colors for these curves. You might want a different color per cylinder, or you might want them all to be blue, whichever you like. I really recommend using some of these capabilities in Onshape. It makes your life a whole lot easier when you're trying to see which bit is which as it goes through in 3D here. I'm going to use my trick again to go front, side, top. Or maybe I'm using my space mouse to do the same sorts of thing. It helps when there's colors to just discern the difference between them. All right. Now, going back to that routing curve, there were a couple of special things. When I did this first curve, the first point away from the origin, where this was the origin, right? I did the first point. I just moved it in Z only. Right, so it's going to be normal to wherever that mate connector was. Now, there's a lot of other controls you can put in with the routing curve, and I'm going to get more of that is going to be evident when we get to the interpolated spline. For the polyline, you can achieve things like run parallel, run normal, all according to the mate connectors that are in there. Obviously, the mate connector is an extremely powerful instrument on its own. So you can make mate connectors before you create the curves, or you can do them on the fly like I was kind of using here. It really depends on the situation as to whether you would create them before or we create them kind of in situ or implied during the actual feature. That is most of what you need to know about a polyline, except for a couple of things. There are other ways of getting vertices in other than just digitizing them like we did. You can actually import CSV files, right? So a CSV data of the X, Y, and Z locations for a series of points can be, you add that to your document and then just import them, and then it will run the curve through them. All of the other same things apply. Once you've got those points in, you can add automatic bend radius to it. In fact, if you want to override a particular bend radius at this corner here, you can. You can say, well, we don't want a bend radius, or we want, a much bigger one. Oops, that's a bit big. That's too big. Let's go to 80. It's still too big. 75, still too big. Okay, 70 would work. Though that's overridden that corner with a 70, whereas the rest of them are 50s. We don't have to override them. We can go back to the defaults. That is that's the main things for this routing curve. Let's just finish that up and go back to where we were. So, as I said at the beginning, the last step for bringing all of these parts together, including the ones that I'd copied these first bunches of parts from the assembly context. The last thing I did was to create a composite part. Now, you've got a couple of choices when you create a composite part. You can make them closed, which takes away all of the other parts, just leaving the one part. And that's what you'd see there. You'd only have this turbo manifold as the composite part. Or you can leave it open. And there might be reasons why you want to keep it open, because you might want to detail an individual runner and also detail the composite part, maybe for a welding prep or some other things that you want to do. So the composite part is there, and so we've got our turbo manifold, and back in the assembly I insert that and I hide the other ones because these are no longer necessary. I've just used them for reference. So my assembly now consists of a bunch of studs for mounting the turbo and my composite part for the manifold. Right, so that's a pretty cool demo. I love doing these ones. There's all sorts of spaghetti-looking creations that I've created as part of the preparations for this feature that we've just released. But I've got another really interesting example here that I kind of alluded to at the beginning, and that's this robot arm. This robot arm, and I'll turn off the wires for a second. This robot, it's nice how you can do this. You can hide everything in a folder just with one click on the folder, and then unhide it again at the end. We're constantly putting little usability things like this in as we go, and Onshape gets better and better every 3 weeks, of course. Actually, I want to show you a quick one here. That's the same one best back over here. Right, so we've got the this robot arm, and interestingly, just a quick backstory. This is an open source project out of France, and I've got no affiliation with them. And it's an AI-informed, trained robot arm. You often work in pairs like this, and I've been building one. And in fact, this is a picture a few minutes ago on my desk here. So here's the Onshape model, and there's the actual software that's called Phosphobot that I'm running, which is the development kit, the development platform for actually training and running these robots. Anyway, I've got really into this project, and I thought it'd be a really excellent one to test some of these things out on. If you can see, obviously there's a little controller here for the USB to the servo connections. The servos are mounted in a very smart way as part of the structure of the robot. And you see there's an in and an out for each of the servos, and they daisy chained to each other through a series of cables. And what I wanted to do was to create the routing for those cables, just to check that the lengths would be pretty nicely achievable with the pieces of wire that I had. And so what I wanted to do was just run a single wire, not doing 3 at the moment, just run a single routing between all the reds, the red to red here and the red to red up the next one. And I'll show you the final effect first. So you can see here the first wire from the first servo comes up, goes under that, and then the second one jumps out of there and follows this interesting routing through or around the side of this arm, and it's got a clip for it, and then it comes out a little bit and goes into the next servo. The top arm has another little channel for routing the wire, and then there's the last two wires. One comes over here and goes underneath into that servo, and then the last servo goes from the wrist to the claws at the top there. So it's a nice little series of wires that are going to be plugged in. They're all around 140 millimeters long or something like that. They come with the servo. The idea with this kit is that you can build everything with just the 3D printed parts, and I spent 12 hours printing these. You can just do it with your own printer, create these parts, and then you buy the servos, and they come with a bunch of screws and wires, which are the only things you need to put the whole thing together. It's a really, really cool idea of the builders of this project. Like I said, it's an open source project. There's plenty of links to this online. So how did I do these? Well, it was a similar process from before, where I would create an assembly like this and create an in-context part studio. So let's go to that part studio now. And if I show you the context, again, you can see I can adjust the strength of the viewing of that context. Sometimes it helps to have a little bit stronger like that. And you can see a previous design in here. Anyway, so what I did was do a series of features where I would create a mate connector on a reference surface like the bottom of this stub of wire. And as you can see here, there's a mate connector there. And then I would create another one on some sort of routing along the way. Maybe you can see here, I've offset that surface by 1 millimeter, and I've put a mate connector right there on the edge of it. And so in this method, I'm creating a bunch of mate connectors, and actually I'll roll back to here. You can see those mate connectors there's 1, 2, 3 mate connectors, which constitute the journey that this wire has to make under here, up through here, and end up ultimately at that finishing point. And at this stage, I would create a routing curve, right? And just as you saw before, I would have the routing curve, but instead I would just choose these mate connectors directly. You can see here each of them refers to a mate connector by name. There's no offsets from them because they're going directly from the, from that. Now, these magenta lines are very important ones. And if I take one in the middle, for example, this magenta line, which is now this big one, is what we call the derivative, or it's the angle or tangent that the route is going to make as it passes through that point. And you can control not only the direction, but also the strength. So imagine that you want to keep this wire as straighter as possible as it goes through that point. Now I'll just try and come around here. Yeah. So this is called the derivative, and you can trigger that on. And then you can also say that the derivative is supposed to be in a specific direction, either the X, Y, Z, or some other given direction. And you can use all, edges, faces, mate connectors, cylinders, whatever else as a direction finder for that. So I've got this direction finder as the Z axis, or the blue axis of the mate connector that we had created on that little reference surface there. And then there's a derivative on this last one, is I wanted the wire to come in normal to that face as well. So that's normal to that is meaning the derivative in that, again, blue direction. So there's a lot of controls there in the routing curve, purely through the use of mate connectors and derivatives. And also, the kind of symbiotic relationship between the mate connector and the reference geometry that you're gathering from the underlying assembly context. Phew. Okay, so what does that mean? It means that let's roll to the end and let's make sure that the context is updated, and you'll see that Okay, so now that we've got, that was from a previous update that we had been playing with. This was a particularly nice routing. I sort of did the trench run, I guess, if that means anything to people. I ran through here and I did a couple of spots along the way to make sure that it stayed kind of parallel to the floor and that it popped out in the right place, and then turned the corner and attached itself to the reference that I wanted to. Right. So that is an in-context part studio. Now, the red bits here are just sweeps that I made along the path. You can see here that I actually created the routing curve of those black things, and the sweeps are things that I made after the fact. Now, I'm not going to dwell on them for the moment because there's a million different ways that you can do sweeps and lofts, and you can use custom features, whatever. The most important thing here is the routing, and you can see here, some of them are around 140. There's one shorter one, but mostly around 140 to 145. And I haven't got too specific about that yet. I've been playing around with getting this demo ready, so some of it's changed. But you'll see that if I look at it from this side here, and if I go back to my photograph, well, actually, that's in a different configuration, isn't it? So what are we going to do now? We will look at my named positions, and I've got a bunch of different named positions, including, I think, the one that I used for this. There you go. So it's a little bit of an angle, 60 degrees in there. This one's horizontal. Let's see if that's the right one. So if I change to that named position, you'll see that now the wiring's all messed up because it was based on the context from when this was in position 1, or the flattened position. So what we have to do is update the context, and it tells us that because this little blue dot says updates available for the context in this folder. This particular one, I'm going to right click and say update the context, and now the wires will be updated, and you'll see here they still run according to the mate connectors, even if the orientation of some of these has changed, of course, right? And that's the point, that these wires will move. Now, it's not a wiring analysis program. It's not going to exactly do the snap through that a real wire would do. It's not going to warn you if you kink it between two parts, but you can certainly get more than enough information at this point of the design to understand whether that is a reasonable way to route the wires. And if I look at my image, you'll see that they are indeed routed in exactly the same way. Which is no accident, because that's what I just built. So that is a really nice, I think, use of routing curves to provide the guides that you're going to be using for doing other things, like whether it's flexible hoses, rigid pipes, maybe even frames if you're using frame features. The routing curve is so flexible and so powerful that it's really going to take, I think, a while before people can fully, exhaust all of the possibilities that are in that feature. And like I said at the beginning, it's an exciting release. They're all exciting releases. This is a particularly exciting release because there was so much other stuff that we did talk about previously. But I'm particularly proud of the routing curve, and I'm looking forward to seeing everybody's efforts with it.